So in the last video, we basically saw how similar the electrostatic force and gravity are, just with a few caveats about watching for minus signs every now and then, just to do with the fact that for gravity, forces are directed inwards when we're thinking about our standard case, whereas for electrostatic things, we're normally thinking about forces directed outwards, unless this Q ends up being negative, and then we've got a negative charge in our centre. So that's kind of the reason why we have that situation there. But otherwise, very basically the same. We just have to make sure we're talking about positive stuff and making sure we're watching our minus signs, but otherwise everything seems very similar. But there are differences. There are some actually quite important differences. So that we have seen they are very similar, and we can simply swap mass with charge and everything basically behaves more or less the same. We just have to watch out for some minus signs. There are important differences. So these are kind of qualitative things rather than things we can point to with formula. But the idea is that everything feels the gravitational force is one difference because everything has mass. So charged objects feel both the electrostatic force and the gravitational force, but neutral objects only feel gravity. So far we've kind of talked about this like it's one or the other. Either you feel the gravitational force or you feel the electric force. But actually the idea is that you feel both if you're a charged particle. All these things we've seen before, so for instance with this electron here, this also has its own gravitational field, just like the Earth does. So this has an electric field it generates, but it also has a gravitational field, whereas the Earth just has a gravitational field. It's not one or the other. It's not either you experience gravity or you experience charge, you experience the electrostatic force. It's that you either experience one or you experience both. You can either only experience gravity or you can experience gravity and the electrostatic force. So that's a big difference. So for instance here, if we look at these two charged spheres, they're going to experience the electrostatic force repelling each other, but they're also going to experience gravity pulling each other in, Fg and Fg. And these two neutral spheres here without any charge, they're still going to experience gravity, but exactly the same amount as the ones above. So what we see is that actually gravity is not unique to just the one without any charge. They both feel it, but they also, the charged one also feels the electrostatic force. So either you feel both or you just feel gravity, but you can't not feel gravity. Everything feels gravity. But we will see there's an important caveat to that in a moment. The other thing as well, I know this is kind of just down to a minus sign, but it is really fundamentally important as to how these forces are different to each other, is that gravity is only ever attractive because masses can never be negative. So in these formulas we were seeing here, we have M1, M2, we have Q1, Q2, but this formula can be attractive because Q1 and Q2 are allowed to be negative. This could be negative, this could be negative. M1 and M2 are only ever positive, which means the force only ever points in one direction. It's only ever attractive. Whereas for electrostatic forces, they can be both, depending on Q1 and Q2, because we don't have that limit that Q1 and Q2 are bigger than 0. So that's why gravity is always attractive, whereas electrostatic force can be attractive or repulsive. So in this situation here, it's actually an attractive force we get as opposed to this one, which is an repulsive force. So these ones are attracting each other because they've got opposite charges. Opposite charges attract, like charges repel. And the final thing that's kind of, well, one of the final things which is very important.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.